Hello, everyone. I'm Brady Volpe, founder of Nimble This and a Volpe Firm. Welcome back for another episode of Get Your Tech On, our show on all things DOCSIS. Today, we're going to be talking about PNM Services, added value, and benefits for cable operators. With us today, we've got three great guests on our show. First up is Todd Gingrass, VP Solutions Architecture, CCI. Todd, welcome to the show. Please give us a brief introduction and let us know where you're broadcasting from.
All right, thanks, Brady. Todd Gingrass with CCI Systems, broadcasting from the Great White North in the Upper Peninsula of Michigan in Iron Mountain, Michigan. Been with CCI for 25 years and hopefully 25 more.
Awesome. Todd, thanks. Glad to have you with. Next up is Bill Halvorsen, Solutions Architect, Access Technologies, CCI also. Bill, glad to see you with us.
Brady, it's good to be here with you.
Bill, also, where are you broadcasting from today, Bill?
I'm in North Carolina, right outside of Raleigh, on the north side of Raleigh, not down there by Siler City or anything like that.
Fantastic. And also back with us, as typical, is John Downey. John, good to have you back. John, you're not in your normal location today. Background has changed a little bit.
Yeah, well, that could be just I moved to a different room in my house, but that's not the case. I'm on vacation in Myrtle Beach, North Myrtle Beach. So, that's the beauty of virtual meetings and the things that we do, right? And ubiquitous Wi-Fi, usually no matter where we go. So this is great. And I'm probably 50 miles from Bill, maybe. You think, Bill? Probably you're north of Raleigh. I'm west of Raleigh, where I live.
Yeah, no, I appreciate, John, that you're able to make it while you're on vacation. So thanks everyone again for joining, and also everyone that's listening live on the chat room. Please post your questions in. Before we get started, love to have you subscribe if you have not already, and also hit the notification bell. You'll be notified on podcasts, and please do give us a thumbs up. That helps with the algorithm for YouTube to let us know that people are liking what they're seeing. So our topic today, PNM Services, added benefits for cable operators. So as you know, Nimble This provides PNM for cable operators. PNM is proactive network maintenance for anyone who's not aware of it. One of the features that it does is it really helps identify issues in the RF plant, helps cable operators, particularly now when so many people are working from home, children are learning from home. The goal of PNM is really to identify problems that subscribers may have before subscribers really even know that it's a problem. And one of the opportunities with PNM for cable operators is when they're using PNM, particularly maybe they're starting out with PNM and they've not used it before, is this, the topic here is really to how can we better help cable operators accelerate their PNM program. So PNM expertise is something that everyone's learning to gain and move on. And we kind of want to talk about that in this segment, in this session moving forward. So that's why we've invited CCI on to talk about that. They've had experience with that, and we want to talk about that moving forward. So I'd like to introduce and kick off this meeting a little bit. I'll start off with a little question for Bill Halvorsen. Bill, you've had some previous experience with PNM, and I'd like to ask you, from your point of view, maybe one of the challenges you've seen with a cable operator when they've started working with PNM. When an operator first starts to work with PNM, maybe you can explain what your experience has been with some of the early learning and early growing pains they may have had.
No, thanks, Brady. And I think some of the key aspects of that is, most operations that have RF technicians and are reacting to trouble calls and problems when, again, without PNM, when you're normally monitoring a plant, it's, where the pain is, you go. And a lot of times, especially the small operators may have 3, 4, maybe 7 technicians, and they're really just, 40, 60, 80 hours a week going out and fixing things that are problems that they at least know about. So the concept of PNM Expert and the service side of that is giving them a little bit of breathing room, having someone that knows plants, and again, CCI has experts that have been doing outside plant work for 30 plus years. Those taking that knowledge, looking at the information and the data and the maps that you have in PNM, and really helping operators get ahead of that curve, right? Get ahead of, just firefighting. So, we're not going to be out there doing the truck rolls, but we are going to be doing the analysis and helping them find those problems that they can start taking out before customers are calling in. And that's the critical thing is getting ahead of a network down situation and really improving operations.
All right.
So let me add in, Bill and Brady. I always thought it was funny. I've been doing this for 25 years or so, 20 with Cisco, and then it was with Secor, right? And then WaveTech. So I've seen the different sides of it. And we used to call it mob bell status monitoring, because you would wait for somebody to call in with a problem, and that was your status monitoring. So it was always tough to justify the cost of actual status monitoring, power, cost, maintenance, whatever. And then we said, when high-speed data came around, we're like, I used to troubleshoot by disconnecting things to find out where the noise was coming from. You can't do that anymore. It all has to be in service, no out-of-service testing anymore. So for us to be able to utilize equipment in the field to have visibility of problems without disconnecting an RF leg, without causing, we used to call them the 6 dB wink switches, right? Where in the amplifier you could do a 6 dB wink switch. Well, that was cool to see if the noise in the head end dropped by 6 dB, but if you didn't do it fast enough, the modems would rearrange because they're trying to keep a constant level with the CMTS. So now that it becomes an issue. Those things kind of went away. That causes more cost and more problems with those wink switches, so you don't see them very often. But to be able to do troubleshooting and monitoring in service without disconnecting anything, I think that's the big power right there. And the fact that COVID and all these problems with the pandemic don't allow technicians to go into a house anymore, that, how do I get in there or schedule time to get in there? So I think it's critical. The other thing I want to bring up wasn't PNM free from Cable Labs? Like, you didn't even have to be a Cable Labs member. There was a website you could go to that was open, but you really need to know what you are doing to make your own PNM application.
Yeah, so
correct?
Cable Labs came up with the PNM technology. They created the reference design. You really have to be a Cable Labs member to download it, or at one time they had it kind of posted up there, and you kind of had to sign some stuff on a Cable Labs website to download it, but it really wasn't something that could be easily operationalized. It was kind of like a reference design of kind of here's how it works, but good luck getting it up and running with a lot of modems.
Yeah, that's just the software too, because and Brady and we've talked about this for the past 6-7 years that we've been doing this. Everybody, all the C's, all the big boys, all the little boys, try to write PNM software. Just the software by itself. Don't include to be able to actually interpret it and make actionable plans. So it's not an easy task just to get the software in a space and an ability to be qualitative enough so you can do the RF analysis, right? So there's, I think we're solving that first piece today. The PNM software that Volpe or Nimble this offers, that the package that Larry has at Comcast, the software and big data, machine learning, those things are all gelling well together. You still need that expertise and someone like a John or a Todd or one of the experts that we have to really look at the data and now say, this is a tap issue. This is the part of the line that we need to send a technician. That's the secret sauce right now.
So while we're on that, Todd, I want to take a step back for a moment. So I know that CCI does a lot of plant work, a lot of maintenance and stuff like that. would you say that you see are sort of some of the major RF related issues that would fall under the sort of the firefighting type of realm that cable operators deal with, or that you as CCI deals with today?
Oh, absolutely. So the largest is, when you really think about PNM, is crack cables. We see that a ton. And many times that was something that was left alone. They wouldn't even really realize that it was a problem. Maybe it's leaking or not, right? Putting leakage out, and they wouldn't find it. But, and especially in northern climates where you have a large expansion and contraction of cables every year, year over year, happens underneath shrink boot by connectors. You see that a ton. And we can really start finding that from a PNM perspective, where before, if a technician can't visually see it, it doesn't exist, right? Or you have to then, you're tearing apart the network without knowing where the problem is, which, as John talked about before, right? That's a no-no. If we're going to do that, we're going to do that at 3 a.m. And even that's a no-no now. I mean, someone's downloading then because everyone else is on the internet. So you have to have something that'll narrow things down for you. And then all the other elements that do not show themselves, that are not obvious, right? Where you can see if a drop wire is frayed or broken on the connector, but water inside of tap plates and housings, or housings being warped and bent, most of the time the human eye can't visually see that until someone has pointed you there, and you actually know where to look at it. We see a lot of problems that are found by using PNM because of that type of correlation, right? It brings the data together. It uses like you said, mass data analytics from all the modems, and pinpoints you to that spot. And now we can find those problems so much easier.
No, I think that's really good. I want to shout out to Hi Elaine. Thanks for mentioning water ingress, connector issues. All of these are good, but crack cables, I think that's a really interesting point to bring up, because I'm not sure that experienced technicians will understand the importance of crack cables, but technicians who haven't had a lot of experience with crack cables may not understand necessarily the root cause. But what they'll start to see is, when you get a cracked cable, that creates a micro reflection. Yep. And when you have a micro reflection, when a modem transmits its signal up to the CMTS, some of that modem signal is going to be reflected back to the cable modem. And so what's going to happen now, we have cable modems that have to transmit at a higher power. Same in a downstream. The signals going down to the cable modem, some of those signals are going to get reflected back towards the CMTS. True of the video signals as well. And now, if we don't realize we have a crack in the cable, that micro reflection, we can start to do things to compensate for that without understanding it. So maybe we're going to adjust a pad in the amplifier, or maybe we'll make adjustments elsewhere in the plant, start changing tap plates out and things to maybe get those cable modem levels back to where they should be. So we're never really getting back to the root cause of fixing that cracked cable. We're just compensating it for other areas in the plant. And same to Elaine's point, where she said there's water ingress or we have connector issues. If we don't get to the root cause and resolve the water ingress, resolve the bad connectors that are all causing issues of signal loss and additional attenuation in the plant, we're really just creating Band-Aids, which later on we're going to have to go and fix those Band-Aids after we do fix the root cause.
And Brady, I actually, sorry, John, for cutting you off for once. I had to put that in there.
Oh, that was good.
I have actually great story about that exact example, and you might remember this, Brady. And we were trialing PNM in Mexico. And we were picking these hotspots in this operator, maybe a couple million subscribers across a large city in Guadalajara. We found this hotspot, and we said, hey, there's 600 MAC addresses, 300 subscribers actually being impacted by this problem. And we pulled up the map and we showed the customer and the customer said, oh, that can't be a problem. It's brand new. It's a new MDU. We extended it just like 9 months ago, and it's all brand new. It's all brand new. The buildings are brand new. The coax is brand new. And we said, and we were showing them this in PNM, and we were saying, but the science is telling us that there's a large microreflection and ingress noise in all three, or actually all four of these towers. And because PNM could give us a echo cavity, we knew a proximity where that problem is. And the customer finally, we were throwing them a lot of data, a lot of science, and they finally said they agreed to go and do a maintenance and go look at it. And I have a picture of it. They literally have a trunk. They had a node feeding a line extender into the MDU, and we went to the line extender and we showed them right exactly where we think the problem was. They pulled back the boot, and the installer 9 months earlier had cracked the cable, covered it up, put the boot on it, put everything together. And 3 weeks later, when we had a review with the customer, this thing came up with them, and they said, you know what we found out after you fixed it is because all the trouble calls went down by 20%. Customer satisfaction, or the customer churn rate, went down by 30%. And what's key about that is it was a problem they didn't even know about, because the call volume, they accepted what the call volume and the trouble tickets coming in for that MDU was okay and normal, because that was their baseline. And it was until we showed them with PNM that there was actually a problem and actually an issue, they went and fixed it. So it was a pretty great example of the power of the science and the data, but it also took our expertise to walk them through the logic of why we wanted them to go there. So I wanted to throw that story because that's a practical, it wasn't 30-year-old cable that got that developed the problem, wind stress on aerial cables or anything like that. This was an operator self-inflicted wound that they thought was okay because the call volume and everything that they were seeing in their data looked normal. So,
yeah, very good. So, John, I know we cut you off. We're going to give you a second there to collect your thoughts and get back in.
So one, I was going to say, Bill, so you're dropping knowledge? Dropping knowledge. So for Todd, I'm curious as to the cracked cable, what it manifested itself in the PNM. A lot of people think of PNM as reverse pre-equalization taps, all that stuff. But I suspect you could also use the full bandwidth capture. Downstream levels look bad past the common point of the problem, and you track it backwards.
Oh, absolutely. Yeah. And when you think about it, like it was Brady said, micro reflections right away were blatant and obvious. But then again, PNM is one piece, right? It's always putting together the other data that cable operators have collected for years, but haven't always correlated those different data points together. So you did see problems in the downstream signals too. And when you talk to an operator about it and they start seeing all the different light bulbs that they were all turned on, but nobody was putting them together, then they start realizing and learning, wow, how powerful is this really? What else can I do with this? But some simple problems that, again, as Bill's example was there, people take things as status quo. And the biggest thing we've seen is repeat truck rolls to places because they think they've fixed something, or especially with a cracked cable, it comes and it goes with the wind, right? 1 minute it's reflecting, the next minute it's not, and then it is again, and then it's not, because the plant is always a living thing. But micro reflections are huge, to answer your question. I mean, that's a huge.
Let me ask you this. Let me cut you off there.
Yep.
It's only fair, right? I've cut everybody off. Made part of the club now.
Your equal opportunity.
You should feel honored. If I had a micro reflection there from a cracked cable, and you guys come up with the PNM cavity, if you will, and you looked at the maps, would that cavity, you would assume, was whatever next splice or amplifier or tap? That would be the cavity? Is that sort of what would normally show up?
Yeah, I mean, yes.
Because it has to be a micro reflection between 2 points. This is not a micro reflection going back to the modem. It's usually indicative of micro reflection in a cavity. like 2
Yeah,
points going backward.
if I get that lucky to have that cavity, right? So it is 2 points.
Yeah.
Then we find that. Otherwise, it is the why am I losing so much power, right?
Yeah.
The design is the design for a reason, right? And a lot of people would, have the design of their outside plant, and those levels at that amplifier don't match, and they would just go with it. So, change the pad, change the EQ. It's okay, it's running. Well, it's
Yeah.
not okay. There's a reason it's not right. It should be really close to that design.
That's why I think full bandwidth capture would capture
Yeah,
that stuff, right? High end roll
absolutely.
off.
Right.
What scares me is what if you're trying to do a 1.2 gigahertz plant, but you're only loaded out to 800 megahertz today?
Right.
You might not see any high end ringing or standing waves. Like Larry
Right.
brought up, I think last week, right, Brady, water and drop cables. It wasn't really a standing wave in the lower frequencies. It's more up at the high end because you end up with maybe worse return loss at higher frequencies. So
But
it always behooves us to test all the way out.
And real quick, Brady, I'm going to interrupt you because I agree with John. But some of the other things is a couple of things. PNM allows us to do all this remote. So I could sit here in North Carolina and troubleshoot problems in Australia, which I've done. The other thing is you can look at all the neighbors. So to your point, you start seeing maybe you have a correlation group, maybe you have a cavity, but you can also start looking and to your point about using full band capture. I think some of the other indicative things that Ron Rannick would point out would be like suck outs and other things that come with these problems, and you can see those. And one of the points that you were talking about, the 1.2 gigahertz plant, is a lot of operators don't think about turning on an OFDM channel that they're not going to use and see what it looks like on their full band capture. Todd and the team actually have proven out a lot of operators about why going to a 1.2 gigahertz system, even though you're going to only do a 1 gigahertz plant because of the performance range. But we can do things with our knowledge and show customers how to turn up channels on their CMTS so that can help the outside plant guys isolate problems like you were describing, John. Sorry, Brady.
Thank you, Bill. And I don't mind being interrupted. One of the things we covered last week, John, it's come up a lot of times, and this is true. We've been saying in the industry for years and years, is that low frequencies cannot jump and high frequencies cannot swim. And so the point of that is high frequencies do very poorly in water. And that's kind of what we were covering with the episode last week with Larry Wilcott when we were talking about water soaked cable. High frequencies get attenuated very, very quickly anytime you have water in coax. Low frequencies can't jump. So anytime you have cracks in coax, particularly radial cracks, very small cracks like that, that's when we have low frequencies really, really see that impairment much more significantly than high frequencies. So if we talk about full band capture, seeing a very small radial crack, we may not see that with a high frequency. We'll see it much more substantially when we look at the low frequencies, which are return frequencies, and they also tend to impact our return frequencies much more significantly than our high frequencies, because high frequencies can jump across that radial crack, but the low frequencies cannot jump across that radial crack. So when we talk about PNM and we use all the capabilities of PNM, which means using the pre-equalizer and the return to look for things like small cracks and small micro reflections, it's really, really effective for that. Using full band capture is really good at identifying other types of impairments, like suckouts, stub cables, water ingress, and things like that. So a nice thing about PNM is it is a nice toolbox of capabilities to look at things like maybe radio cracks for low frequencies, water in cable, group delay, a lot of the impairments that we would normally not be able to see with a typical handheld troubleshooting meter. And so I put that I guess I just want to cover those two areas on it.
Yeah, I'd add in a big one would have been the old days when people were trying to core out hardline cable, and they score the center conductor, and it's copper clad aluminum, right? So if you end up scoring the copper, now you have what you would sort of like say is a radial crack on the center conductor. And we all know about the skin effect. So, higher frequencies are near the edge of the copper. But yeah, anytime you have a little gap, like a loose Caesar screw, the lower frequencies always just die off. The higher frequencies can kind of jump the gap, almost like a capacitor. And like Bill said, it's understanding how RF works and having years of experience of looking at sweep traces and troubleshooting, and then try to interpret that from the information we're getting back from the cable modems in the form of pre-equalization taps, full bandwidth capture. It's basically a sweepless sweep now. If we have full channel loading, we have a full spectrum trace. I could take that, all those channels, normalize it, and then compare the end of line to that normalized trace. So here's my, point A to point B signature.
Yeah, so and that's a really good point, John. So we're seeing in our Nimble This PNM application, a lot of operators that are starting to just use it as their sweep. So we can use full band capture and a downstream. It gives you pretty much a nice clean sweep. If there's no issues in a plant, as you're saying, John, you can see all the RF channels, every single RF channel, all the way to a subscriber's home looks nice and flat. If we have impairments, then you start to see standing waves, you start to see suckouts, and that's a very quick way to go end a line anywhere in your plant, and it doesn't require anyone going out in the field. You got it anywhere you want, in your office, on a handheld phone, etc. Same in the return. What you're talking about, a loaded return, you're basically looking at the top of the cable modem haystack. So we talk about these haystacks, but they're actually completely flat on the top. If you don't have impairments in a return, if your return is nice and flat, you can look at all the in-channel frequency response across the top of in the Nimble This PNM application. It looks like a sweep response. So now you can sweep your return, you can sweep your forward to the end of line anywhere in your plant. And that's really a powerful capability. So I would say, I would again go ask CCI or ask Todd or Bill, throw this back to you guys. That's a lot of work that you guys spend sweeping, and I would be curious how you see PNM being a value add to that.
Yeah, and that is the absolute value add. So we've been helping operators sweep for years, but adding PNM, we know money doesn't grow on trees, right? And it's hard to sweep a plant, hard to afford sweeping a plant. We have to use technology to make it more efficient. And owning it, we own some systems ourselves too. So we've taken that exact approach. So when we think about the transition that we went through from DOCSIS 3.0 to DOCSIS 3.1, and that was the real catalyst of PNM, right? It was written into the spec, it was there. So now more of the modems had that on board for sure. We obviously had some prior that had full band capture capability, but we started deploying, put some near the node, put some midway, and put some at the endpoints. Even if that subscriber was not buying a package that, let's say, required that 3.1 modem, we knew they would switch out eventually, but that gave us those starting points to do exactly that. Let's use data from, crowdsource that data, bring it in. How can we look at all this information and compare which one is not like the other, right? And you'll find quickly, and then as we add more and more and more, that really started to show us where the problems were without sending the tech to the field. Now, when that tech did go to the field with his meter, he was on a pinpoint mission, right? It wasn't just run around and look at everything. You still went to the field, you still had to find the problem, but you had a whole lot of data. So it's helping us when we still sweep again in our own systems, but in systems that are, for our clients that we work with. Absolutely. If they have PNM, it's the greatest thing ever to blend that together with all the other data points and make things just more efficient for the operator so they can get done quicker. I mean, let's face it, they don't have the amount of technicians they need, and people have turnover and they don't have the training that they need. So this just helps them become so much more efficient, keeping the plant good. And at the end of the day, bringing revenue in for them requires good customer satisfaction. And that's what this all rolls up to, is customer satisfaction.
Yeah. And Chad Keys, one of our directors of outside plant operations that does the sweep and has the people doing the sweep. We were on a webinar just a couple of weeks ago, and PNM allows you to extend the life and value of that sweep, meaning you may have to do it every 2.5 years because you had no other visibility, and that costs you that comes out right out of your OpEx, right? You don't get anything back from that. PNM can extend the value of that sweep. So you still need to do your sweep, and you still need to do that deep inspection, but you may only have to do it every 3.5, 4 years. So you're gaining, you're not losing any visibility. Going back to the example I had earlier, between sweeps, you don't know what you don't know. You don't know what's happened to the plant. You don't know how it's changed. You don't know who's backed over a pedestal or where lightning has hit, right? But with PNM in play as a augmentation to sweep, allows you to start noticing, and that's one of the things that is critical about PNM is we measure in the tenths of dB of change. And I don't know, I think it was Ron or maybe John, even it was you years ago, told me about only 20% of the plant problems are instantaneous, where, like I said, someone backs over a pedestal and rips the trunk cable right out of the ground. Everything else that happens in the plant is that radial crack or that a water in a tap, and then over time, the weathering and the corrosion and PNM and pre-equalization and DOCSIS will mask that for you for a period of time. Could be months, could be even years. But and early on when we had pre-equalization, I had customers tell me I'm going to turn it off. I don't, and we're like, my God, this is the greatest feature ever. Pre-equalization will help you keep the plant healthy longer. I said, but why do I want to wait until it rolls over and more subscribers go offline because the problem got so bad? And they were right. PNM now gives me that view into small incremental changes that are happening, and the reports that are in PNM and the way of data looking at it across days, weeks, months, years, you can really see where things are going before a customer even knows or you see any impact.
And just one more point on sweeping and where we're getting this data from. So, I mean, all this data is coming from cable modems. I don't want people to forget about the fact that we have power supplies out there with cable modems in them. So that becomes one more data point in the outside plant that we're able to sweep to, that we're able to get this data from, both upstream pre-equalization data and downstream full band capture. So I can have a shout out to Alpha, which we've been meaning to have Alpha on the show for a while now. Alpha makes power supplies, and they've been putting DOCSIS 2.0 modems, DOCSIS 3.0 modems, and now DOCSIS 3.1 modems as transponders in their power supplies. So if you're getting those, I highly recommend getting the modems in the power supplies, because those are very, very valuable pieces of data collector points throughout your plant, where you can now start sweeping through and see where problems may be sectionalized throughout your plant.
So don't forget to put a baseline test modem in the head end.
Oh, yes.
To alleviate the entire HFC plant.
Absolutely.
That way you have like a clean modem. But word of caution there is the spec for a modem to be online and transmit is a huge window. Don't ever put a cable modem in the head end and hook it up to a downstream upstream connection without proper diplex filter isolation and proper padding. If I set up a cable modem in the head end, and because it's not going through that entire cable plant, and it ends up transmitting 20 dBmV, it'll work. The spec says it can work, but it has almost 40 dB of range left in its transmit window. So if anything weird goes on, it can find a path through all your splitters and combiners and isolation, port-to-port isolation, and end up at another port somewhere, and you didn't realize why. Or if it goes offline, starts ranging, if it has 40 dB more range, it's going to overload the other modems that are trying to come in. So it's imperative that we set up our test modems that are transmitting, say, close to 45 to 48 dBmV. That way you have the proper padding in there and force them to transmit higher. And even if they go wacko, they don't have 30 dB of range left. They're already at 48. They might only have 3 dB of range left anyway, because they're doing 4-channel upstream bonding. One other thing on, if we do downstream sweep, I've seen this with the distributed access architectures and remote PHY, your head end goes away, your RF stuff goes away from the head end. It's all digital fiber out to the node. how do I fill up that spectrum? So I came up with a way to turn on DOCSIS single carrier QAM signals and call them a video channel. And without tagging video content, I can do it for free without requiring a license. The problem with the Broadcom chip and the chipset is the last single carrier QAM is 999 megahertz. So if I want to see the spectrum out to 1.2 gig, I have to do OFDMA or OFDM, and I haven't figured out a way to turn that on for free. You have to have a 3.1 license to turn it on.
Yes.
So just some more information.
John, your point on putting a reference modem in the hub is spot on. And I think that's really where this whole PNM expertise comes in, of knowing like things to look for. So we've seen quite often where every single modem off of a fiber node is bad. And that gets you automatically thinking, well, it's got to be the fiber node. That's not always, well, sometimes it is the case where the fiber node is bad, but sometimes it's the head end wiring. And that's where it is nice to have that reference modem in the head end to be able to move it around and say, well, is it the fiber node, or is it a bad cable, a bad connector, a bad combiner in the head end? That we also want to test that. And that reference modem in the head end can very quickly, we move it to where that fiber node has come off, we can very quickly troubleshoot an issue in the head end.
I'll give you a case in point. I decided to turn on more carriers. I forgot to do derating of the carriers going to my laser. I have downstream laser clipping and don't know it. The downstream laser clipping is so infrequent that it affects my MAP messages. The MAP messages affect the modems. I start getting T3 timeouts. I might get bad voice quality, upstream partial mode. UGS voice flows get interrupted even though you think it's an upstream problem. It's a downstream MAP problem. But the modem in the head end is not going to see that, right? Because it's not going through the HFC, it's through the fiber. It's
Absolutely.
always good to have some reference, test device.
Yep. So I would say another question to Bill or Todd. What have customers found value in bringing an expert to look in PNM data? Thoughts on that?
Well, actually, and it's kind of interesting because that's how we kind of got into the discussion at CCI. Is we have a customer that has a PNM expert, and he's been doing it for 4 or 5 years. He's using your software, and he's now retiring. And the VP of operations at this customer is like, I have no one to replace him. And this is a great case because the customer already understands the value. We don't have to show him the value of PNM. He's already seen how much this one guy saves him in truck rolls and keeping the techs focused on what they need to be doing, giving him good information about where to go. But this guy is now 65, 70 years old, which is young in the cable industry, but he's leaving. And so this customer came to us as, can I hire you? Can you do this job for me? And, and we were like, yes. And so that's the key. That's the biggest thing is, you, Larry, John, the industry knows about PNM. I don't think this is a trying to prove a point anymore of what PNM can do. The challenge as operators is I have 3 technicians. These 3 technicians were all trained by the same guy that wasn't trained by anybody else. They all do it the way the guy did it because he thought he saw a video back in 1980 how to tune an amp. And they all do it the same way he did it. So the knowledge base is not there to be able to develop, the experience to do PNM. So I think those are the 2 critical points.
Yeah, and one more that comes along then too is just time, right? The time for the technicians to spend looking at the data, and really it's the term that's been used in the industry, and Brady, I know you use it all the time, it's PNM Champion, right? Someone's got to be that person at an operator that really understands the software and understands what information is coming to them. And as great as it's evolved, and the way it's presented in data to them. They have to have the time to look at it and just know what to do with it. And that's where a lot of operators lack, is having that skilled expertise, like Bill was alluding to there, is having the expertise to then take that data and do something with it. They might not understand how to take the information. It could be staring them right in the face, but if they haven't learned, they don't know how to make the best use of it and get the payback on their dollar that they're spending. So that's where we see we can really help, is we help them be that person. And while we're doing that, their team starts learning and they evolve and they grow. And over time, they start getting better and better at it. And that's where you really inch away at it and hopefully take more than an inch each time, but you start helping them retake back control of their network, not constantly being firefighters, but more, again, it's a great marketing name, proactive, right? Let's be proactive and not reactive. As John said, let's not wait for the telephone calls to tell us where the problem is. Let's find it prior to that.
Yeah, Todd, I think that's spot on about getting out of being reactive, and I think it's really challenging for operators to get out of firefighting mode, because when you're in a fire, and we have been in a serious fire since March, every single operator, every single technician I talk to will tell, and I'm sure you're hearing the same thing. They're going to tell you they are constantly busy. They're working weekends. They're doing node splits. They're doing everything they can. They're just fighting fires since then. But there's still opportunities with PNM to do a lot of help during that time. When you cannot enter a subscriber's house, subscribers are doing self-installs. And one of the benefits of PNM is that it gives you the opportunity after that, before or after the customer has done the self-install, PNM gives you the opportunity to run a complete diagnostic without entering that subscriber's home. And we have a lot of customers right now of NimbleThis, the NimbleThis PNM, that we have the capability to go in, not to the subscriber's home, but in the application, and run diagnostics after the customer has done that self-install, or hundreds of customers have done that self-install, to automatically analyze downstream, upstream, group delay, micro reflections, and see if there are any issues, so that we can then make sure the customer's done that self-install. Are they going to have issues? If they're going to have issues, we now can do proactive diagnostics, not wait till the customer calls, the Ma-Bell diagnostics, as John mentioned, but we can do proactive things to make sure that that customer is not going to have a modem that's going offline in the middle of the day when they're on a call with maybe a business customer, or their children are online and learning. And so these are some of the things that, when we talk about what are the benefits for cable operators, how can we help cable operators, we want to make sure that we're taking advantage of this and communicating those things out.
Let me ask you this, Brady and Todd. I always say I love math. It's a universal language, but you have to have a baseline and you have to know what's expected before you can say what your results are good or bad. You have to compare it, to have a comparison. So my question to you guys is, when you have that diagnostics from the modem, do you have the information from the cable provider with their strand mapping to know what level you should have? Or you really don't get that information? The reason why I'm saying that is, like, when I look at modem's transmit level and its downstream level, I know how frequencies work in coax, and I know how frequency loss works in flat loss. So if I see the downstream level is low and the upstream level is high, I might think it's high flat loss, like a high value tap, or someone put a splitter in, or something. If I see the downstream level is low and the upstream level is low, it might be long coax, because I can think with long coax, higher frequencies drop more. But lower frequencies don't really get affected by that coax loss like the high frequencies do. So I can make some assumptions, but it'd be good to know what the strand map says should be at the side of the house, so that when I look at the modem, I can compare and say, it's in spec, but it's not even close to what the math says. You understand?
Yep. Yeah, absolutely. And that's the key, right? And that's taking the data and then having the experience to apply it, right? What is it supposed to be? That's huge. And for so many years, that's what's led us to firefighting, right? Is because we let it be good enough and not looking at that. So when we can get our plant back to, let's get all of our technicians heads above water, right? So they're not firefighting, and that may be perfect world, especially right now, as Brady said. But when we can do that, and they can start taking that approach of what's it supposed to be, and as you said, there is a reason when it doesn't match, because design softwares from whoever designs your plant, the actual reality is fairly close when you take care of your plant. It's not okay, perfect, like you said, math, perfect world math, right? And when I did my design, but oh, it's always 5 dB off of perfect world design. Well, what would be the point of design then, right? If it wasn't going to be close, that's factored into the design softwares. There's theoretical and then there's reality factored in. So you absolutely need to be matching to your design. We get that's perfect world, and how do we have time to do that? Well, we have to strive for it as an operator. When you do strive for that, and you work on this, and you will get there, as your teams continue to embrace, especially data, right? As soon as they start looking at data proactively, you can go to the house without going in the house and knowing many times what that problem is. So when you do enter that house, hopefully you're not in there for a 4-hour service call, because subscribers love that, hunting around the house looking for the problem, right? You've got a pretty good idea. They probably, like you said, inserted a or did something, or maybe it's just outside of the home. You're going to figure that out, because downstream to upstream ratio, what is it? What's it supposed to be? I can see what's happening.
We're hoping that the newer architectures end up being a gateway in the house, right? And there's no coax in the house. It's all Wi-Fi 6. It's all Ethernet. But don't we have a PNM for Wi-Fi as well? Isn't there something like that for Wi-Fi?
Yeah. Yes. So there's a PNM Wi-Fi working group that has been in process for a while. One of the challenges is the PNM or the Wi-Fi Alliance has to still make sure that the new Wi-Fi equipment coming out has the hooks in it for us to be able to get that data out and analyze that data. We'll still have subscribers that have old equipment, however, for quite a long time. The same way that we had DOCSIS 1.1 modems when we started out with PNM, and we had DOCSIS 2.0 modems, and even still we have DOCSIS 3.0 modems that don't support full band capture, or the older modems that I mentioned are not fully DOCSIS compliant, and we have challenge getting the data. We're going to have those same growing pains with PNM over Wi-Fi, but we're very, very close to getting there and being able to start having that capability to know when there's a problem in the subscriber's home with Wi-Fi. We're going to be able to start understanding what those problems are, not only understanding what those problems are, but being able to proactively address those problems, because it's many people know 60% of the CSR calls, or it varies from operator to operator, are Wi-Fi related. And once we can start getting ahead of those and addressing them, and then making recommendations either to upgrade Wi-Fi in homes, add mesh networks to homes, that's going to be a fantastic capability to provide for cable operators.
Yeah, it'll be the next problem, right? It's like we trade one problem for another. People are like, well, if I do fiber to the home and I do Wi-Fi from there, there's no RF, there's no problems. I'm like, yeah, but the Wi-Fi is probably 2.4 gigahertz, which is the same as your microwave oven, and all the other stuff that's free and open in the air. So we're just trading one problem for another. So yeah, we might not have upstream ingress like we used to, but now you have Wi-Fi. You still have a customer service or customer experience problem, right? We still have to address the experience.
I think the biggest thing about the Wi-Fi inclusion to PNM is the ability to pull that data into all to like what Todd was saying. Now that I have data coming in from the Wi-Fi modem, and depending on the Wi-Fi manufacturer, I can look for nanometer 5G. I can look for new sources of problems that may not affect my Wi-Fi, but I could say, hey, I see this high ingress noise, or this high ingress coming in. I'm detecting it in my Wi-Fi, but I'm also detecting it in my cable, on my cable plant, right? So I could actually start correlating that I may have a new 5G antenna in a neighborhood that's not properly powered on, right? I mean, that happens. I mean, the wireless industry is not perfect. I've heard a lot of stories about even when LTE was coming on, how they would max power and they would just, no matter how clean your plant was, they were leaking in all over the place. And that's one of the cool things about the PNM software, being able to identify LTE carriers inside your plant. But I think also the other critical thing was in the PNM software being a data platform, a data analytic platform. And John, to your point, if I can go back 3 weeks or a month and see a trend, and see that my ingress or my SNR or my micro reflections weren't that bad until this point, and it's now bad, that gives me some indication too. And the fact that I can go look at the neighbors in that incident and see they're not seeing that problem. That's an in-home wiring problem. Now, if I see that, if I can go to the neighbors that one guy's calling in, I have a problem on my streaming's not working, or I get pixelization, whatever. As a technician, I can go look at the neighbors and not see any of that same problem. But then I look at that particular one. That I don't have to worry about the plant. I don't have to worry about it. It's a drop. It's a home issue. I'm already done. And I can do that for technicians 24/7, so that I give them a nice long list of in-home wiring problems that they can either hire a high school. And this is the other great thing about the service aspect, is the other realms of an operation. We've been very focused on how this helps the technician, but PNM and then the expertise that PNM provides also helps all sorts, because if you have a list of in-home wiring problems that you can identify, hire a high school kid and call up the customer and says, "Hey, you have an in-home wiring problem. Can I, and we see it. We know it's in your house. We've checked your neighbors. It's in your house. Hey, can we, for $40, we'll send a technician to fix it for you." And I
suspect a lot of people would say, "Well, just tell me what to do and I'll try it first."
Well, maybe that's something we can do, but you can resolve. Ultimately, the problem's going to be in your. It's going to affect your plant in some way. But if you can, think out of the box, because again, we've been very focused about talking how this can help a technician. But if you give the birth certificate capability, or if you give some of the tools that is in the PNM software to the call center people, you're usually on hold 15, 20 minutes. They're going through their long script of things. Have you powered on the modem? Have you raised your left hand? Have you done the hokey pokey, right? But if I can hit a button as a call center at CSR and really know that you have an RF problem in your house or don't, I can skip half that script. I save the operator money. As a executive owning the cost of all those technicians and the call center, I can save you money. And I think that's another key aspect of the value of PNM and PNM service.
We get it. It saves money.
All right. All right, gentlemen, we're coming to the top of the hour. I want to cover a lot of good content here. I'd like to start off with you, Todd. Anything you want to plug coming up?
Boy. Coming up is we're going to see more bandwidth.
Yeah, more bandwidth.
We're going to see a lot more bandwidth drain on the network, which is going to exacerbate problems and people calling. So as cable operators look at this type of technology and take advantage of it, who knows how long this is going to continue to go on. So start taking advantage. That's all I can say really is find a way to be more efficient and take care of your subscribers so that you can continue being the operator of choice in this very bandwidth driven world that everyone's relying on right now.
As a Cisco partner, I love what you guys do. You're very knowledgeable in Cisco stuff. So I appreciate when I pass the buck to you guys that I feel safe that you're going to do the right thing. And it gets people off my back as well. What's your take on rural broadband and the earmarked money for rural broadband and people moving rural, like Bill and I have both done, and more people moving out? And my theory is it's like the Wild West. If you build roads out to other areas, it gets developed. and it generates economy. But I don't see node plus zero being a viable option for people that live a mile apart. You
Right.
know, so if it's not node plus zero, node plus one, FDX is probably a non-starter. So it's probably going to be, DOCSIS 4.0, extended spectrum DOCSIS with a diplex filter split in the future. That's like a 396, 450 split or something like that. For now, I think 204 is perfectly fine. And we have CPE on the market today that support 204 megahertz upstream. So I think in that realm, it's great. I'm just wondering, because you support a lot of those systems that are rural. And then the announcement that AT&T is giving up on DSL. So I think that means AT&T Uverse is gone, or they're not going to generate more. I don't know if they're going to do something else with rural broadband, maybe run fiber deeper, but it's still got to be a money issue there, cost.
Right.
What's your thoughts?
I didn't know that they were still in the game to give up on it, but
DSL's dead.
I thought that battle had ended a long time ago and we were just fighting PON. But no, I mean, even 85 megahertz right now is huge, right? I mean, when you think about usable spectrum, really in most operators' plant, node plus 6, right? Usable spectrum is really 20 to 42 if they have that, when you really get down to it. So going to 85, look at how much we've just increased the actual spectrum in the upstream. So even 85 is something big for people to be looking at and how to handle this bandwidth. But rural is right. I live in rural completely. Our systems we own are very rural. We've got thousands of miles of plant and in the thousands of customers only, less than 10,000. So you do the math, right? It's a big deal. So the rural funding is really big. And let's face it, it's going to go into a lot of different technologies. Some will be for HFC. A lot of new builds, it's hard to argue that you wouldn't put in some type of fiber to the home technology if you're building brand new. But then also when you're way out, you're going to have fixed wireless, without a doubt, for the right applications. But for the operator that needs to just fit a few areas or add on and such, they need to make those type of adjustments, and it's definitely going to grow your network as makes sense. We help a lot of operators figure out what that is too. It's HFC isn't always the right answer, but it's for an HFC operator already there. It's what they know, and sometimes that's what makes sense.
Are you seeing more push to digital fiber?
Absolutely. The distributed access architectures are huge. I mean, it gives you plant improvements like we've been talking about also, right? Without a doubt, it takes out 30 years ago of HFC plant to today, it changes the game completely. We've been doing that since 2017 with a lot of operators and ourselves. We're all remote PHY on our network right now, nice. and it's really helped the performance.
Yeah. Okay. Thanks.
All right, guys, we gotta wrap up here. Brian Wilson says he's still on DSL, so DSL is not dead. Elaine says in rural PA they are using the funds to the wireless or not the broadband funds to fund fiber to towers and unlicensed wireless. So
hey,
funds
Brian,
are going to different places. So
DSL doesn't mean dumb, slow logic. So
so John, what do you want to plug? What do you want to plug coming up? Any plugs, John, for yourself here?
Yeah,
Expo?
so SCT Expo next week. It's going to be, it's going to be busy, right? I'm sure all of you are getting an onslaught of emails and updates, and make sure you do register, because I believe you can't just register and get into a session. There's 30-minute blocks, or it takes 30 minutes for them to process your registration. But I thought it was only Tuesday, Wednesday, Thursday. There's a whole thing of stuff going on Monday. Yep. There might be stuff going on Friday. I'm talking at 9:30 on Wednesday, the 14th, and at 1 o'clock. So I'm in two different sessions. One's on COVID and capacity concerns, and the other one's on the power of DAA. So just like you talked about, Todd, distributed access architecture, digital fiber, there's a lot of advantages. And the biggest one is no laser clipping, perfect signal. Obviously and I think Brady and I talked about doing what are the pitfalls maybe to DAA? Like no one ever wants to talk about what could go wrong. And I'm not afraid to talk about the good and the bad and the ugly. You just deal with it, right? And you learn to how to compromise. Say, all right, I understand those pros and cons, and I'm going to go forward.
All right. Thanks, John. We'll see you next week. And Bill, anything you want to plug on your end?
I forgot what the question was after that.
Any
No,
plugs?
we're like Todd said, we're getting ready to launch our PNM Expert. So that's taking up a lot of bandwidth and opportunities to talking to people about that. I'm actually getting ready to write a blog about Fi Anywhere, because remote Fi, remote Mac Fi, PON, they're all Fi, and they're all viable for our customers. So I'm going to be writing some more about that.
All right. Thanks, Bill. Thanks, everyone, again. Thanks, everyone who's watched and stayed on this long. If you're not already, please do smash that like button if you like the video. That really helps with their algorithms. I will be moderating and presenting next week at Expo. So, again, do sign up for Expo and take advantage of all the sessions that will be there. What
day are you on?
I'm at 10 a.m. next Wednesday, and I forget when the other session is. So the sessions are all listed. So everyone, again, thanks for tuning in. We really love you watching our episodes. We'll be back in a couple of weeks with another session. So long, everyone. Thanks for tuning in. Bye, all.
Take care.